Hey everybody, this is Larry. I'm doing the Leetcode Weekly Contest 179. Um, yeah, wish me luck as usual. We'll need it. Hit the like button, hit the subscribe button, leave your comments however you like, and I'll get to them. Um, right now I'm in uh, Long Prabang in Laos. It's kind of quiet here, which is kind of good. At least for me to do the code. And yeah, okay, 10 seconds. So let's do this. Let's go. Contest Q1. So the first one, generate a string with character with odd counts. I think I knew how to do this immediately because it's not a, but it's just one of those fun problems where it takes me a couple of things, a couple of reading, um, just because I don't know, sometimes without like a set thing, it's a little like a set input output. Just wanted to make sure that your assumptions are right? Because um, there are definitely strategies, and for these kind of problems, they will try to trick you with inputs outputs that are not optimal or easy to program. So that's kind of the general thing. Uh, what I did is if n is 1, then you just return one character. When n is a even number, then you just break into two pieces, one with one character and um, one with what we call it, one with n minus 1 number of characters. And then otherwise, in order conditions, I just take one off the top and then to a mini recursion because now it's a even number, right? And this will only recurs once, so I don't really worry about it. But yeah, but after that, I was just like testing a few more just in case, and like some obvious test cases just because it's easy to do that. Uh, Looks okay, and then I was like, okay, done. This one it actually took me a little bit while to read. Um, I think this probably could have been worded a little bit better, but which all turned on both up. But yeah, I think it was just really wordy. And also in the beginning, I looked at the example without the actual input, so I was like, huh, I don't understand what this is supposed to mean. But then I looked at it, I'm like, oh, okay. So yeah, make sure you actually look at the input and not just pictures. Um, but but yeah, I think I think my immediate reaction to this, to be honest, is to use binary index tree. I think I really should have done it that way. Now that I'm thinking back, the reason why I didn't was that I was like, that seems too intense for a medium, for a quote unquote a easier medium even. Like maybe there was a easier way. So I was just thinking a little bit. I think I'm still understanding the problem here, to be honest, because you look at moment 3 and you're like, well, or like, why is it that moment 1 it's brewed immediately and not just turned on or something like that, right? So it's a little weird. But the way that I landed on was that given um, given an index, uh, you just have to check that all previous verbs are on, and you could check that if all the sum is from 1 plus 2 plus 3 plus dot 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 all the way to index, which there's a easy formula, index times index plus 1 over 2. So that's kind of essentially the idea that I play with. To be honest, I was very much not confident about that solution because I don't know if there's some like weird um, mathematical properties that not weird, just that I'm not familiar with it. Where I was like, is there a way you can like, is this forced? Like, is that always true, or is there like some thing where that just turned out to be not true? But yeah, we'll see. that's kind of my strategy. Now I'm looking at the sum, and then yeah, if also get the index, and then this is just a standard formula. I think I could change the formula, but then instead I want to change the index just so that I don't have to. It's less confusion. For me anyway. Your mileage may vary. I just didn't want to think about like, I don't know, changing the formula and then just like an off by one, and then I don't know. But here, I'm at about 4 minutes and 50 seconds in, so I guess the running time did, oh no, not really. Okay. Because here it looks fine, but as soon as I hit submit, you could kind of see that. Actually, I waited a while for this one. I was just like, okay, let's look at the next one. And looking back, because I get distracted. But yeah, time informed too. That's not good. But yeah, for this one, I think I was just trying to grasp the problem and the input. I thought it was going to be like the longest path from root to the leaf immediately, but I think initially I was not looking at the informed time parameters. I was like, huh, why are these answers like weird? Or specifically like example 3, I was like 21. Shouldn't that just be 6 or something like that? Because I thought it was like 1 minute to each note. And then I was like, oh, this is an informed time. So that made it kind of more obvious. And I think unlike the recent problems where they give you the tree to begin with, here you have to construct a tree, which I did. That's how I start. So now I'm just converting from this parent hierarchy to parents down, so I could do a top-down recursion instead of doing some weird bottoms-up thing. I guess we could. Yeah, I think at that point, I was just trying to make sure, like, do I have to keep track of who the head boss is? And then I noticed that they actually just tell you, so I didn't have to do that. And now this is just a very standard depth of search or just recursion from every boss. It will. I think I'm just in this point just formulating how to describe the problem very accurately, which is okay for this boss. The cost of me to tell all my reports, that's the cost. And then now I was like, okay, well, what is this actually asking? And then it's asking, okay, actually, well, first of all, you want all this child, and And I'm trying to figure out how much does each child contribute. It doesn't make sense because they happen in parallel. Because initially I was just going to sum them, but then they happen in parallel, right? So, so I was like, okay, what is the, and it's just the max path, and that's pretty much what I did. A lot of copy and pasting to kind of get the inputs, which is kind of annoying, to be honest, because this is about 10 minutes in. I wonder if the top here just kind of, but yeah, I mean, after that, I tried submitting it, but it still took a lot of penalties. So yeah, I mean, I just took so much time writing these edge cases, like minutes, right? Like it's been a minute and a half now, and then even then, um, the reason why I wanted to code every time is because I was like, this takes long. It takes longer to run code before I submit the next one. So then, when the last case was okay, I was just like submit, and then this takes a while. Yeah, frog position after 2 seconds. So as soon as I looked at this, I refreshed to see how many people have already done it. We're only 10, 11 minutes in, but actually not that far from someone finishing it. But yeah, this one, I think I knew how to do it immediately in two ways. I knew it was going to be dynamic programming, and the other is with matrix modification or Markov chain, transitional matrix, and so forth. I thought that the dynamic programming was going to be a little bit messier. It didn't, but that's what I did at the time. I was like, okay, maybe I'll try something new today and do the transition matrix with the Markov chain stuff. And this is way, this actually, and I was looking at pending just to see, why it didn't get, or whether it gets accepted. I get distracted by that a little bit, as you can see. But yeah, I think I was starting with a dynamic, but I think my issue here, and what my particular issue is, so it depends on your strength and weaknesses. I think at this particular time, I was trying to do bottom-up dynamic programming it immediately, and I didn't really think about. I didn't know if there was an easy way to do it bottoms up. Maybe I should thought about it a little bit longer, to be honest. And if I had thought about it a little bit longer, maybe I would have done it that way. But instead, I think I was trying to also at that point read up on what gets a fox stuck on an island or whatever it is on a node. So then try to calculate that math more precisely. But yeah. Yeah, here I'm just trying to think whether it makes sense or not. Oh my. Yeah, and here I was trying to do bottoms up, and it's not so that every iteration we simulated. Um, but I mean, and actually, kind of thinking about it wasn't that hard. But it's just that I was like, okay, I also know that I could use matrix multiplication. I'm actually very confident about this, except for that I think when I did the math on the bounds, maybe on Python it's a little bit too slow, and that ended up being an issue, as you will maybe see, unfortunately. For me, well, there was another issue, but yeah, for more, if you want to read more about this, just read Markov chains, and this is actually a pretty, I would say, it's a pretty standard Markov chain thing, if that was the case, and actually, for large enough T, dynamic programming would stop working, and then this solution works because you could actually do matrix multiplication in an easier way, I think. Maybe I'm wrong on that one, but it is fancy. It's way too fancy. But right now I'm just constructing. I'm converting a list of edges into an adjacency matrix. Adjacency list representation, so that I could do the math easier later. This really should be more straightforward, but yeah, so that's just standard converting the H's in this. I think I was a little bit rusty today, because that particular piece I shouldn't have taken that long in typing it out. But yeah, but now I'm just setting up the probability matrix, which I first does what I do. So this basically what I'm doing is trying to impose a structure in this, because you can never go back, and because another thing about this input is that because it's a tree, you never because it's a tree, you never could go back. So your states will always be progressing toward your end state. So that's kind of what I do here. Just constructing it. I think I'm wrong. Well, it is incorrect as it is right now, because I go back and forth. But then now, and this is actually straight DFS kind of, just kind of explore the tree, like unwrapping the tree, if you will, so that we kind of see where all the leaves are. Yeah, I just want to print it out just to see what it looks like. And then you give it an error, but at least it, no, and I saw the last one got accepted finally. I was like, okay, don't have to do anything fancy. Yeah, and I just don't return the thing, so I was like, okay, let's return something. Yeah, at this point I'm already 8 minutes in, so kind of suboptimal the way that, maybe 7 minutes, but yeah, because there's a lot of unfamiliarity. I mean, I've done this before and probably many times, just not very recently, maybe not in the last year or so. But yeah, here I was like, okay, node 2 should not go back to node 1, so I look back here and I'm like, okay, I actually have to do some filtering or whatever. Basically, you just don't, basically just removing the back edges. There are a couple of ways to do it, and I'm I don't think the way I did is particularly clean, actually. Um, but this only gets constructed once. I could afford to be slightly whatever, and it's O of n, this particular piece. And here's the matrix multiplication. I feel like if I'd done this in any other language, it would have been fast enough. Or, well, not any other language, but like a C or a Java would be fast enough. But I didn't, so. I think constructing way too many objects. But I don't know. I don't know how much optimization I need for this one. But yeah, but this is basically it. And then now I set up the initial conditions for the Markov chain. Um, oh yeah, here I'm trying to figure out the because I don't really take care of the end state ones, the leaves of the tree. So I'm just trying to figure out how to, if my intuition is correct, which is that if it has nowhere else to go, then maybe that's fine. That means it's a leaf. Yeah, if it's a leaf, then just make it always go back to onto itself. I was trying to think about the edge cases, whether that's always true or whatever. So I was reading the the problem statement just to clarify. Uh, and here, this is probably my only real mistake. Well, okay, maybe the other one, but this is one of my mistake is that I don't know. I just don't know how to multiply. Don't know how to do the power function correctly. And I probably could have, like I said, done this in log n time and it would be okay, but I didn't want to. After this time's out, I didn't want to try it again. So yeah, you have some error on dimensionality, but otherwise this is done and quote unquote good. This is about 23 minutes in, so if I submit this now and correct, I'll be in this top 20. Well, I guess I would have always spent time on typing, but so even if I did in the next 2 minutes or in 25 minutes, I would have been top 25. So that would have been great. Do this one. It's just that I think for this one, not this one, but it's because I haven't been practicing. I think I confused uh, 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 a matrix with one row with with a what you call it with a vector or an array. So that's why I had some issues here. Um, Otherwise, this was actually mostly done at 24 minutes, minus the off by one, which you'll see in a second. But like I said, not familiar with how I done this. I think that's where the tactical mistake was. Uh, really fast. Wow, congrats. Should have just done dynamic programming, to be honest. Yeah, after putting it out, I was like, oh, seems okay, to be honest. So I was trying to figure it out. Then I found there was a matrix, so then I was like, okay, let's print this, and then why not return it? But I don't know. When you're in debug mode, you're not, and when I'm in debug mode, that means I'm already lost half the battle, and I'm like not 100%, and I had to print it out, and then I was like, okay, let's run it. Yeah, and then after that I submit, and then I get a wrong answer. It took a long time too. And then I was like, huh, what's this wrong? So I've tried to suss it out, and turns out all the example cases, the time step is longer than the intermediate ones, if you will. So that's why I didn't catch this off by one, but if you look at how I formulate the power, I noticed that should have just done dynamic programming. There's such an obvious dynamic programming. And the point was would have been top 50 if I submitted by then. Well, I was already top 50 because I guess 49 people submitted or something. Yeah, I looked at the vector and I was like, oh, that is just not right. Dumb mistake, but actually this isn't even. But yeah, but right? Here I knew that I fixed it kind of, but it wasn't. There's still a case where if t is 0 or something like that, then it would be wrong. Yeah. So I had to create the identity matrix, which I did incorrectly, by the way. If you kind of see it, that's not the identity matrix. So it was a good thing that I test this, and it actually worked for this particular case. But that's why you always keep testing. Dumbass mistake. Yeah. Still though, in the sense that if I had just done the more obvious thing, but also it was so slow, and I was like, oh, that's wrong. That's not right. Okay. This particular piece is an easy fix, or at least in the theory part of it, the coding is also easy, but just had to catch it. But that's also another thing where, like, when you're unfamiliar or you just haven't done it in a while, you make silly things where you're like, oh yeah, that's obviously not the identity matrix. And then here,
That's why you always
once I got
test your
that, I was like, okay,
code.
let's, you want to be a little confident. That looks okay, let's go. Unfortunately, spoiler alert, it gets time limited. So at this point, even with the 5-minute penalty, if I had gotten it right, it would have been 35 minutes. So it would have been top 100. Maybe, looks like maybe 70 or something like that. So it's kind of sad. I was like, oh no. And then I was like,
That's what I get.
I was debating using NumPy and converting it, but I wasn't even sure that it's supported by Leetcode and how to kind of clean that up. And then I'm like, well, that's what I get for being fancy. I looked at the leaderboard a little bit just to kind of get a sense of how fast people did it. I was like, okay, just do a dynamic programming. You know you wanted to do. And then that's essentially what I did. Yeah, with the recurrent. I mean, the concept is basically the same with the matrix multiplication, except that we set up the transitions. Well, we set up the transitions in pretty much the same way. So I actually end up using a lot of this code, which saved me a couple of minutes, I suppose. But I ended up only needing 6 or 7 minutes to type this out. I mean, obviously, if I start from scratch, it'd be a little bit longer, but I would have still. And also, the 2 wrong submissions cost me 10 minutes, which is really expensive because I'm not fast enough for that not to be a thing. So we use this to kind of construct the DAG, the DAG, to create the directedness. But that's pretty much it. And the recurrence is each node and each step was the probability of getting there. And everything is linear, as linear as in linear algebra, which is why you can do these kind of sums, which is maybe a little bit more of math that would be a little bit hard to get into. But that's kind of how I mean, the fact that it is linear and in the sense that it's linear algebra is how we're able to do the matrix multiplication stuff earlier. But yeah, but that's pretty much all my commentary. I mean, I think I type it out. I don't think I pretty much actually got it in the first try. And after testing it, I just submitted and it actually got accepted really quickly. So I felt a little dumb for trying something new, but it was fun. And you know, at least for now, I mean, I am a little bit torn because you could say that, you know, at least I learned something, which is great, and you know, it's good to learn, but you know, not every time not every contest you get a chance to finish in the top, I don't know, 20, right? And I had the chance there, but I threw it away to try something new. Like I could have learned at another, like at a contest where I'm not doing so high, and this is the only reason why this contest didn't go so well. So, well. But yeah, but otherwise, yeah, that's all I have for this one. Stay tuned for, you know, chatting with the other big guy. I hope that isn't a double submit. I got it right anyway. I should have done that to begin with. That was just dumb on my part, trying to be fancy. Okay. What is there to say? I mean, I don't know. I mean, I think I did pretty okay. I think I should have just done the dynamic programming one. It was pretty straightforward. I probably, well, I mean, without the even without the two, well, it would have been top 100 without the two wrong submissions. But now with the two wrong submissions, it's kind of terrible. But but yeah, I mean, I think I got it right, except for the time limit thing. And there was an off by one, um, which would have been harder to do with dynamic programming, but or at least maybe I'm just more practiced. So I was trying to do something new, uh, and didn't work. But I probably should have done that even at the slowest, like 15 minutes. So I would have finished in 25, 26, would have been top 25. But I think, I mean, it's easier to say that when you're, uh, when whatever. But instead, I spent an extra 10 minutes and so 20 minutes penalty in general. But eh, at the end of the day, it's about showing up, and I didn't. That was pretty fast too. I mean, after three problems, I think I was near the. I thought I was doing really okay. Maybe a little bit slower actually. I feel really fast today. Um, but still, like it was, I was in contention to be near the top, but I tried a fancy technique instead. But yeah, let's go over the problem real quick just to see. Oh yeah, generate a string with odd integers. I did in a minute 47. Yeah, I think I spent a good amount of time just reading this one just to make sure that I understand it because you can return anything, and that's why it's kind of sometimes tricky in the sense that like you don't know how to validate if your stuff is right. But yeah, but otherwise it's straightforward. My strategy is if n is one, you just return one character. If it's even number, then you return um, this number n minus one, which is obviously odd, plus just one character. And then other than that, if it's odd, I just self-generate just minus one from and then take one character and do it again and wrap it like a sandwich almost. But pretty okay. Uh, Second one, I was actually pretty proud of this one. People got it pretty quickly as well. Um, but I wasn't sure I would make. I was trying to think in my head to prove it correct, where I don't know. Maybe there are other ways to sum up the prefix. I was thinking about using binary index tree, and I think that is probably how people did it so quickly. Because I think with binary index tree, you don't really have to think about it. You just do it, and you could do an n log n, which is fast enough anyway. But then of n, it didn't cost me that much time to be honest, so that's fine. Um, oh yeah, I didn't actually explain. I just said what I did. But the idea is that on a prefix um, or on a number, when you hit, that means that the prefix contains all the numbers from 1 to n, and then if you sum that up, if you've been keeping track and you sum it up, it should equal to that. I was thinking maybe there are ways to kind of accidentally get the wrong number, but because you're given the index, um, yeah, there should be only one forcing way, because there's no like zeros to give away, so all the numbers have to be there. Um, Time to inform our employees. This was pretty straightforward. I was having issues with the servers. I don't know if these timings include depending or whatever, because I thought I was pretty fast on these actually, to be honest. But that means other people are faster. So yeah. But yeah, this is another tree problem. Pretty straightforward in the sense that well, what you don't what the thing that's different about this one is that, and it took me 6 minutes. I don't think it took me 6 minutes, so maybe there was the pending one. I did, maybe, I don't know. Um, but uh, but yeah, for this one, I think the trick to noticing is that if you have, and I don't know if this the example cases suss this out, because I don't think it does actually now that I'm looking at it, um, which is that you have the longest time it takes is the longest path and not the sum of the paths, if that makes sense. So that's why I did this max thing here. Um, and that's the cost of telling it its child. But essentially, that's pretty much the trick, if you will. And then the longest path from the tree to the root from the leaf is the answer, and that's kind of just that's the algorithm. I think I was trying to be a little bit too fancy with this one. Um, I mean, it's a little tragic anyway, but hmm. I mean, because I did really well in the first three, so and I knew how to do this one immediately, to be honest. So that's why it's a little sad. It's not like I didn't know how to do it and then have some issues and I had to discover it, which that happens and that's fine because I feel like then I'm learning, I'm discovering and stuff like this. But this one I knew how to do it immediately. I knew that there are two ways to do it. One is by matrix multiplication, which I thought the constraints would be fast enough, but I guess I didn't actually do the math, which is 100 cubed, maybe I times 50, so that's 50 million instructions. I think, to be honest, I think um, if I did this not in Python, this would be fast enough. But I still had an off by one, so that's a thing. But because I was also doing a thing that was just haven't been accustomed to in a while, um, yeah, then I was just a little bit rusty, and therefore you saw that I had an off by one, which cost me 5 minutes, even if I had gotten right. But it would have been, I think it ended up taking about like just having to resubmit because of time limit cost me at least 15 minutes, which would have been pretty critical. I don't know. I think my strategy was dubious to begin with, I guess. But yeah, from when I first saw this, I knew that it was going to be, or I had two ways to do it. One is with matrix multiplication, because just without going into a lot of math, that's just how you could do it. And there was a way to speed it up with um, with two things. One is maybe I should have used NumPy to be, because there's some optimizations there. Both in the two optimizations I could have done. One is matrix multiplication, could have done in a faster divide and conquer way. Two is that you could do repeat doubling, repeat squaring to get log of t instead of t. That would have been faster. That would have been much faster, and maybe time would have fit in the time. But that was probably not necessary. The other way that I was thinking was, which is what I implemented, which is with dynamic programming. I was thinking about just doing it with the old, just a regular dynamic programming, was just the way I did it with the cache, which is also in the matrix. It turns out. I did, use this from yesterday, so that's kind of cool. But yeah, the idea is that the idea between the dynamic programming is just that because you can't go backwards, and this is a tree, you don't have there are a lot of things that you don't have to consider, like this the nodes that you can possibly jump to are limited as a result. So you can definitely so that makes it a DAG. and that makes it dynamic programmable or memorizable, if you will. And that's essentially what I did. I just look at each child and look at how many, and this just imposes an ordering from the root to the string. I could have done this a little differently. I could have made some optimization to make this cleaner, like removing, but that's fine. I like the way that I did it. I think I'm okay. But yeah, unfortunately, I mean, I don't know how quick I could have done this. Let's just say I would not have gotten the two wrong answers and probably saved like 5 minutes, say. So that would have been really fast, and it would have put me in the top 10 if I had done it, obviously. Or not top 10, top 25. If I had done it, I don't know. But I think the little sadness that I have is that I knew how to do it exactly, and literally I just kind of try to be fancy with the matrix multiplication, which is actually a really cool way of doing it, but it times out. So maybe it's not that cool if you don't get it right. but but there is a different way to do it. I think that's what I was trying to do, learn a little bit in practice. But yeah. Yeah, that's all I have for today. Thanks for your support. If you're following, leave some comments. Hit the like button, hit the subscribe button, leave a comment, good or bad. Tell me what you think about Q4. Should I have done it the other way? Or clearly yes, maybe. Or maybe just like it's okay to experiment. Uh, Thank you, and I'll see you next time. Bye bye.